talk about dealing with our significance tests for P, or proportions, today. And we're going to discuss talking about our conditions that we need to have met before doing anything, which you guys will understand that, as well as we're going to talk about dealing with our test statistic. Alright, so our test statistic, which again, that is just referring to your z-score, okay, the z-score value. And then we'll also talk about dealing with the test statistic and p-value, okay, to understand where we're going with to move forward in calculating the overall null hypothesis and alternative hypothesis, okay? So for our conditions, again, everybody should understand, for the most part, we need to have random, right? We have a random sample, right? Simply could be like a simple random sample that may say in the problem, that may just say random, things like that, okay? And that's the first condition you have to be met. Now, the second condition that needs to be met is going to be your 10% condition. Okay, so in other words, the sample is going to be less than 1/10 of the population, okay? Now that needs to be met for us to be able to move forward with the actual equations that we use to calculate for standard deviations and means or proportions, things of that such, okay? That's what the 10% condition clarifies for us. The last thing that we need to worry about is where we can make sure that we have a approximately normal shape in our distribution for our sample. We want to use large counts. So we want to have large counts, okay? So large counts, again, your sample size times your proportion needs to be greater than or equal to 10, as well as the sample size times 1 minus your proportion has to be greater than or equal to 10. This allows us, this gives us the ability to say it's approximately normal. Okay? That's what determines if it's approximately normal shape for our sample distribution that we did. Okay? So that's what we need to worry about first. So we're going to talk about conditions here. And let's go into looking at a little sample on these conditions, and just to ensure you'll see what we need to talk about and how it needs to be listed out.
Hi, this is Jason Molesky. In this example, we'll take a look at checking the conditions for a significance test of a population proportion. Specifically, let's check the conditions for performing a test of the virtual basketball player's claim that he can make 80% of his free throws. And recall the required conditions are randomness. Note we can view the set of 50 shots as a simple random sample from the population of all possible shots that the virtual shooter takes, so this condition is met. For the 10% condition, we note that the outcome of each shot is determined by the computer's random number generator, so individual observations are independent. We're not sampling without replacement from a finite population because the applet can keep on shooting, so we don't need to check the 10% condition. Finally, we need to check the large counts condition. Now, assuming the null hypothesis is true, this would mean that the population proportion would be 0.80. So we have to check to see that we have at least 10 successes and 10 failures. Well, since we had 50 shots, 50 times the null of 0.80, or 50 times 0.80 equals 40, and n times 1 minus p sub 0, or 50 times 0.20 is 10. Note both of these are at least 10, so that final condition is met.
Alright, so now that we've watched the conditions, understand we need to have a random, 10% condition, and large counts for that. Now let's talk about our test statistic, our z-score, okay? With that, now that we know that we've got an approximately normal setup, to find your z-score in this case, which is also called your test statistic, we're going to simply say, to calculate that, we're going to take your p hat from the sample, right, minus the overall proportion that is given to you, all divided by the standard deviation. Now the standard deviation for these guys is calculated by the square root of your p-value, your proportion, times 1 minus p all over the sample size. Okay, so that'll give you the standard deviation down there at the bottom, and overall this whole calculation will take your p hat minus p divided by your standard deviation there will give you your test statistic or your z-score. Okay, now when you're calculating or trying to figure out your p-value, that should be given to you. Just the overall p-value will be given to you in the problem that's presented to you. So with that, again, if we have a normal curve, right, and we want to find, in this case, normal curve, you have normal, and you want to have the mean for your p-value, so for your p hat, and the actual standard deviation for your p hat. Okay, so to calculate for the mean for p hat, remember we talked about this in a previous section, the mean for your p hat will equal the value for the overall proportion that is given to you. And we've already calculated the standard deviation for the p hat because I just did that to calculate our z-score. Again, that formula is the square root of your p-value times 1 minus p over your sample size of n. So those two values will be able to take care of that. Now, alright, so once you have your z-score, that'll be used to actually calculate, determine your p-value based off the z-score that you get and whether or not you have to find greater than that z-score, less than that z-score, okay, for the area under the curve. So with that, that'll give you your p-value. Let's not forget too about our null hypothesis and our alternative hypothesis. So don't forget that your null hypothesis is going to be, in this case, you're going to be talking about your p, your proportion is equal to whatever it gives you for the value that gives you in the problem. And your alternative, depending upon how the problem is set up, you're going to say that proportion is going to be less than, greater than, or not equal to, depending upon if it's one-sided or two-sided. Again, one-sided is dealing with greater than or less than, and two-sided is dealing with not equals to. So that is how those are going to be set up. So don't forget about your null and alternative hypothesis moving forward with that. To look at the test statistic and p-value calculation, let's look at a little example here to set that up.
Hi, this is Jason Molesky. In this example, we'll take a look at computing a test statistic. Now consider our free throw shooter. Recall that in an SRS of 53 throws, the virtual player made 32. Let's calculate the test statistic. The first thing we need to do is find the sample proportion. In this case, 32 out of 50 works out to a value of p hat equals 0.64. Now to standardize this, we need to take that statistic value minus the parameter and divide by the standard deviation of the statistic. Recall the claim was that he would make 80% of the free throws, so the parameter in this case is 0.80. Standardizing, z equals our statistic 0.64 minus our parameter 0.80 divided by the standard deviation of the statistic. And we know that formula is the square root of the parameter 0.80 times 1 minus that value divided by the sample size of 50. Calculating that, we see that we get a test statistic value z equals negative 2.83. Next, we want to find the p-value using table A or technology. Then we want to show this result as an area under a standard normal curve. Well, using table A, we can find that the p-value is the probability of z being less than or equal to negative 2.83, in this case 0.0023. On a normal curve, we would shade the area to the left of that z value. So we have a mean of 0 under the standard normal curve, a standard deviation of 1, and we can see that the z value of negative 2.83 falls pretty far to the left. Shading to the left, we have our area 0.0023. not very much area there for a very low probability. So what that means is if the null hypothesis is true and the player really does make 80% of his free throws in the long run, there's only about a 0.0023 chance that he'd make 32 or fewer of 50 shots just by chance alone. Seems fairly unlikely. In a few more examples, we'll take a look at how to really interpret that p-value.
Alright guys, so when you're looking at this last little thing for your conclusions, when you're talking about things like that, and you've already got your p-value figured out, and you're comparing that against your significance level, right? So for your conclusions, remember, you're taking your p-value and comparing it to your significance level, whether it be greater than or less than your significance level. Remember, if the p is low, reject the hoe. If the p is high, you fail to reject the null hypothesis. Okay? So those are the big things to get in your vocabulary as well. And depending upon how it plays out, you'll worry about your conclusion. Because if the p-value is low, so the p is low, reject the hoe, then you'll have convincing evidence against the null, in which case you'd be siding with the alternative hypothesis, right? Because you would have the p is low, reject the hoe, so you're rejecting the null hypothesis, so you'd be siding with the alternative hypothesis. As to where if the p-value was high, you would not have convincing evidence against the null, and you would be accepting whatever the null hypothesis is stating. Alright, so hopefully that explains things a little bit better for you. And you learned a little bit of something today, and I'll see you next time.